Today I want to talk about what we call the electromagnetic spectrum of energy. In a previous lesson, we learned a little bit about waves, and energy travels in waves. And these waves have a certain wavelength, a certain frequency, and a certain amount of energy associated with them. So, electromagnetic energy is kind of a broad category of energy, and it actually manifests in a number of different ways. And the way we perceive it depends on the wavelength and associated frequency and energy of those electromagnetic waves. So I want to start by talking about the type of energy on the far right here. Notice this diagram of a wave, and we see it's very long and it's getting shorter and shorter and shorter and shorter and shorter. So on the right hand side, we have waves that are very, very long. And these types of waves, they can be from 1 to like 1,000 meters long, are radio waves, which are used to transmit various forms of communication. Now, from the other notes, we also know that there is a thing called frequency, and wavelength and frequency are inversely related, which means that as one gets larger, the other gets smaller, and vice versa. So wavelengths are radio waves are very long. They have a very high value for their wavelength, 1 to 1,000 meters. Because frequency is inversely related, they have a relatively low frequency. So a wavelength in the range of 1 to 1,000 meters and a frequency in what we call 100 kilohertz. Kilo means thousand, hertz is the unit for frequency. So this is a relatively low frequency. And when we have a low frequency, frequency and energy are inversely related. So long waves have a low frequency and a low energy. As we go along the spectrum, the wavelength value gets smaller. You can see that the size of the waves is decreasing, and the frequency value is getting higher. 100,000 hertz, 100 million hertz, 10 to the 13th hertz, 10 to the 19th hertz. These numbers are getting a lot larger. And as the frequency gets larger, the energy associated with them gets larger. And we kind of find what we know as visible light kind of right in the middle of this electromagnetic spectrum. We have long radio waves on the one end, we have very short gamma rays on the other, and we kind of have visible light in the middle. Relatively speaking, the types of waves on this side of visible light are not dangerous to us. We are surrounded by radio waves all the time. We don't want to really get directly exposed to microwaves because it would heat up the water in our bodies, but infrared we perceive as heat. So these are called non-ionizing forms of radiation, and relatively speaking, they're not very dangerous. So the longest waves are radio waves. The next one along the spectrum, 10 to the minus 2 meters, means about a centimeter, or like less than an inch. That is the size of a microwave, the wavelength of a microwave, and its frequency is higher than that of a radio wave. As we get a little bit shorter yet, we get to what we call infrared radiation. And infrared radiation is heat. If you've ever been to a restaurant where you can kind of see them, putting the food out from the kitchen, you might notice they set the food under a kind of reddish lamp until the waitress or waiter can come and pick it up and deliver it to you. Those are infrared lamps. They give off heat, and they're designed to keep your food warm until it can get to you. So after infrared is what we call the visible light spectrum. Now we see visible light as just white light. We don't really see any color. But if we were to put it through a prism, the prism will split that light into a rainbow. So if you've ever gone outside, Um, After a rainstorm, you will often see rainbows in the sky, and you will see bands of color from red, orange, yellow, green, indigo, and blue. We're going to kind of lump together, and violet. So the water droplets in the air act as prisms that split that light into those various colors. So when we talk about visible light, relatively speaking, the longest wavelength is red, the shortest wavelength is violet. So as we go from red to violet, the size of the waves is getting shorter. It's getting to a lower number. So as we go from red to violet, the frequency is increasing. And as the frequency is increasing, so is the energy. So red is on the long, low end of the spectrum. It has, relatively speaking, long wavelength, low frequency, low energy. At the other end, violet, relatively speaking, has short wavelength, high frequency, high energy. So the wavelength here is 7 times 10 to the minus 7th, 4 times 10 to the minus 7th meters. So 4 times 10 to the minus 7th is a shorter wavelength than 7 times 10 to the minus 7th. So notice that infrared radiation is right next to the red portion of the visible spectrum. So the visible spectrum only accounts for a very narrow portion of the overall electromagnetic spectrum. When we get to the violet end of the visible spectrum, just beyond that is what we call ultraviolet. Infrared is next to red, ultraviolet is next to violet. Remember, wavelength is getting shorter, frequency is getting higher, energy is getting higher. And when we get beyond visible light, these electromagnetic waves have a lot of energy, and they are getting more and more dangerous to the human body. So when we put on sunscreen, when we go out in the sun, we're not trying to protect ourselves from visible light. We are trying to protect ourselves from the ultraviolet light that the sun also gives off. So exposure to too much ultraviolet light can lead to skin cancer, and that's one of the main reasons we want to try to protect ourselves by wearing clothing and sunscreen. Getting shorter yet, higher frequency, higher energy are X-rays. You may have gotten some yourself. You probably know someone who's gotten X-rays. You're somewhat familiar with them. Those have a lot more energy than ultraviolet light, which kind of gets stopped by the skin. X-rays can penetrate the skin so that they can take pictures of our bones. So it's very useful for determining broken bones, for determining whether you have dental cavities, that sort of thing. So they are useful, but we don't want to be exposed to a lot of them. If you go to the dentist, they want to take pictures of your teeth. They lay a lead shield over the vital organs in your body so that they don't get exposed to the X-rays. And if you ever notice, the X-ray technician kind of sets you up for an X-ray, doesn't stand right next to you. He or she kind of goes around the corner behind a wall so that they are not constantly being exposed to those X-rays. So they are good for diagnostic purposes, but we don't want to be exposed to more than we need to. Going further yet, extremely short wavelengths, 10 to the minus 12th meters, are gamma rays. Now, we didn't talk much about nuclear energy, but there are three forms of nuclear energy that are associated with nuclear reactions: alpha, beta, and gamma. Alpha and beta are actually particles being given off. A gamma ray is pure energy of a very high energy and is extremely dangerous to human life. So it can be used to disinfect food. The gamma rays kill the bacteria, but then the gamma rays go away. When they build power plants, they shield them with lead and concrete to protect us from being exposed to gamma rays being given off in that nuclear reactor. So some key points. Radio waves are on the long, low end of the spectrum. long wavelength, low frequency, low energy. At the opposite end, gamma rays, short wavelength, high frequency, high energy. Radio, microwave, infrared, visible, ultra, X-ray, gamma are all different forms of electromagnetic radiation, and what determines the form is the wavelength and the associated energy. When we look at the visible spectrum, red light is on, relatively speaking, on the long, low, low end. Violet light is on the short, high, high end. I am posting this diagram uh, in the Electron resources folder, and your homework is going to be to answer questions related to this diagram. So I've kind of walked you through everything. Then you will actually have the visual to use in completing your homework.